All right, so this is week 9, day 1. Today we're going to talk about the introduction to Amazon Lex. Amazon Lex is essentially the same thing that Alexa utilizes. Like it's the same foundation. Today is going to be a super light day, which is good. We're going to talk about the foundation of it. And although it's a light day, your challenge is going to actually challenge you based off of the lab, the expansion part. You're going to have to do a little bit of research. And today is a solid foundation for the rest of the week. And the week's pretty cool of what you're going to do with this. So although it's going to be like chill and easy, it's an important foundational day. So let's get cracking here with this intro to Lex. So essentially the fundamentals here, overview, here's just a hypothetical. Let's say you've built an individual, or I guess so far you have built individual AI services potentially. Like you've utilized polyspeaks. There's something that you can transcribe listens, comprehend. And these so far you've used them in isolation. But essentially whenever a user's interacting with your product, they don't care about any of that. And they shouldn't notice, right? They shouldn't know, oh, now I'm using polyspeaks and now I'm using that, right? Like you're creating the sense of like cohesiveness. So here's like a little example, right? Let's say a user's like talking to their AI and they're saying, hey, can you analyze the sentiment of this document? And then the AI is like, sure. Like what document? What are you talking about? And the user's like, oh, the customer reviews of our new product. And then the AI is like, cool, got it. Here's your results, right? From the client perspective, it shouldn't feel like, oh, hey, I just interacted with this computer, if you would, and this computer just made 3 separate AI calls, right? They shouldn't care about it. They shouldn't feel that. So instead, it should just feel like a conversation. So, we talk about like UI and UX, user interface, user experience. So what we're doing today is creating, instead of like a GUI, a graphic user interface, it's like a voice user interface. And the experience is just that conversation, opposed to feeling like this procedural set of steps that they're doing. And actually, today we're not technically doing the voice portion. That's going to come later. Today we're going to just do more of like a text back and forth. So what's AWS Lex? It's Amazon's conversational AI service, and it is the same technology that powers Alexa. But unlike Alexa, this is meant for business. So, if you're an engineer, you're going to use this and you're not actually utilizing Alexa. You could, but that's a separate story. In terms of actual construction, you're utilizing Amazon Lex specifically. So you can think of Amazon Lex as a smart router for conversations, right? So if somebody says, hey, I want to book a flight, Lex does not book the flight, right? What does it do? It's going to try to figure out what the user wants. We call that the intent. And it's going to try to gather all the information it needs to fulfill that intent. And that information, it's called, the necessary information is the slots. And we are going to get into this a little bit more as we dive in. So what it's going to do is once it knows the user's intent and like its goal, and it has all the slots filled, the necessary information, then it's going to hand that off to the business logic, the fulfillment. And that's where the flight's actually going to get booked. So it's just kind of like everything else. In fact, I was going to do a little demo, but Nick kind of actually did it, which is why I had asked him for his project, what happens if you don't fill in the fields. Essentially, what these first 2 portions are doing, it's validating to ensure that it has all the proper information. And then when it does, it's just doing the same thing every other interface does, is it takes that information, sends it somewhere else, and that somewhere else does something with it. In this case, it's that somewhere else is booking the flight for the user. So where can you see this in production? Here we have 2 categories, just examples. External and customer service. A user can say, hey, I need to return an item. So Lex is going to collect the order number, the reason. Then it's going to route that request to the inventory system, right? Then that inventory system is going to do its magic and fulfill the return or deny it, right? Who knows? It does whatever it does. Internal for data operations. An employee can say, hey, show me the 3rd quarter sales. And then Lex would authenticate that user. It's going to validate their permissions. And then it's going to send that information to the warehouse, through APIs. So here, essentially, that bot logic you build, it's saying once can serve web chat, voice calls, SMS, Slack. So it's reusable. You can build one bot and then repurpose it if you'd like into different aspects. Why does this matter for your career? So if you're building conversational AI, it should show these qualities. One, it shows system architecture. You're orchestrating multiple services into a cohesive user experience. It shows experience design, user experience design, which in this case of conversations, it would create natural, intuitive interfaces that feel human, right? That this is an illusion that we're creating. It shows state management. That's how you handle complex workflows across multiple conversations. With state management, essentially you can think of it as short-term storage of important information. Because it's like the way that it validates, oh, what's the order number? What's this? What's that? What's the third? It has to house those temporarily at least until it sends it off to the back. And then integration expertise. You're connecting AI services with existing business systems. So just what you're learning this week, you could put all that into like a project, a resume, whatever, and show that bit of skill set. So here's just the thing. It says most developers can build a chatbot, but you're going to build a conversational AI that scales in production environments. So this is the difference between going into like an interview and saying, oh, I made a chatbot. Like, oh, I've made a conversational AI that scales in production environments. Those are two different perspectives of what you've done. So conversational AI fundamentals. This is essentially what we just said, but we're going to kind of jump into this meat. Before we move forward, we just did the intro, but is anyone already lost or have questions, or are we good to keep rocking? All right. So some fundamentals. What we have, the first one is called intents. This is what does the user want? What's the user's goal? What's the user's intention? They're called intents. An intent is the specific goal or action that a user wants to perform. It's the internal label your code will eventually receive. So for here, this is just one example. Let's say we had a banking bot, right, as part of a bank. Some of the predefined intents that the bot can be aware of, these are just examples. It could be to check a balance, transfer money, open a new account. So your AI is going to have, essentially these are, functions, if you would. You can think, or even like API routes is essentially, kind of like how you can consider them. They're predefined API routes and functions that are intentions. And what it's going to do is it's going to try to predict what the user wants based out of its available options that the bot can actually do. Because this isn't just like, back and forth conversation about nothing, especially in a business sense. It's usually the customer wants something. So here it says Lex's job is to listen to the user and categorize their request into one of these buckets. And it could be however many there are. The next phase, which we also talked about, it's actually, we haven't said the name yet, but it's called an utterance. This is how do people ask? Because remember, the AI or illusion of AI wants to know their intent, but it has to understand what the person's uttering. So the utterances are specific phrases used to trigger the intents. Utterances can refer to the training data, and we're going to show you that later today. Utterances can refer to the training data and the actual user input. So there's two types of utterances. There's a sample utterance, and there's a user utterance. The sample utterance is essentially the training data. And the user utterance is whatever a user is asking. So here are some examples right here. If a user says, "What's my balance?" That's an utterance. And it's the AI is going to try to figure out, hey, what's the intent of what's my balance? Like, what the hell is that? And it can infer, if we set it up correctly, it's going to say, oh, they want to check their balance, right? So some other ways that a human could express that, because remember, humans are not pre-programmed, or maybe they are, and that's a philosophical debate, right? But for our purpose, they're not. So if a user wants to check their balance, they could say, hey, what's my balance? They could say, check my balance, check my account. How much money do I have? Show me my current balance. I want to see my balance, right? Now, for us as humans, we're like, yeah, kind of like, no shit. All right, you said the same thing 6 times. Okay. But from a computer perspective, those are six completely different, there's six different strings, that are being, we have our text or our voice, it's going to a string, which would be these, and then the computer has to now infer or estimate what their utterance, what's the intent of their, of what they're uttering. So the more utterances that we provide, these sample utterances, which are the training, the better that Lex would become at understanding your users. But you don't need to capture every possible variation. That would be impossible. But the more the merrier in a sense. But Lex will use machine learning to generalize from your examples. So essentially, it's like we need to give it enough variety, and then it'll be able to kind of infer everything in between. So far we've talked about the utterances, which is the human input. We've talked about the intent, which is understanding the goal of the human input. And then there's something called slots. This is what information do you need? So slots are specific pieces of information you need to fulfill the user's request. You can think of them as function parameters. And it says think of them, but it's like it's kind of essentially what it is. So, but think of them as function parameters for conversations though. So an example, let's say a user says, hey, transfer $500 from my checking to savings. All right, so that could be inferred that their intention is, oh, transfer money. So now the slots, these are the parameters that are needed to transfer money. In this case, they need an amount, $500, the user said it, transfer 500. They need to know from which account is it starting and to which account is it going to, because it's a transfer, checking and savings. And right here, the user said transfer 500 from checking to savings. So my question is, did they provide all the slots? Did they provide all the information for the required parameters?
Yes.
That's right, they did. So right now, that's cool. Bada bing, bada boom, it's going to go ahead and set up that transfer. I would hope in a perfect world, maybe it'd ask if you're sure, but that's not the point of today. So then example 2, a user says, move $200 to my savings account. All right, well, the intent is transfer money. And then what about the slots here? What's the amount? We know, okay, $200, cool. From which account? We don't know. It says 200 to my savings. So right now we have a missing parameter. So when slots are missing, this is when Lex is going to prompt them and say, hey, which account would you like me to transfer from? And then this is the back and forth. It's called slot elicitation. So it's eliciting to get that response for what it needs, additional parameters. So far, if we stop right here, is there any questions about these three, which is intent, utterance, and slots? Okay. Cool. So, I was going to show you guys a little demo because it's a short class. Here, I'll show it to you either way. I'm not sure, just because you guys are pretty advanced. It may not be, let's see. Here's what I'm going to do for you guys real quick, just to show you this. Let me move this out of the way. Okay, so right here on the screen, I have Postman. You don't have to know all the workings of it, but essentially what Postman does is it connects to backends. It allows me to send API, like gets, puts, posts, whatever, right? The same way a front end would in theory. Normally, if you're developing on the back end, I strongly encourage that before creating the front end, you can test out your backend APIs manually. If they work, then do the front end. That's the workflow I use. But anyway, right here, this is going to hit a real backend that's going to attempt to log in the user. And I'm going to let you guys know already that that login API requires a username and it requires a password. So the question is, here, I put in a fake password. What's going to happen when I hit send? Who knows? Does anybody know? And if not, can anybody guess? Essentially, what's going to happen here is the backend's going to respond. Does anyone know how the backend's going to respond if we put in a fake password?
It depends how it's set up.
That's true.
probably respond something like a username with that password username combo incorrect.
Okay. So we're going to hit send. That took a while. Okay. So here it's saying a 401 unauthorized. That's the response code. And for the message, it says email or password not valid. So essentially, Nick, you're correct. This all depends how you set up. You can pick the wording. Just side note, usually if you're validating, the backend knows if the username or the password's like not real, but you
You don't
never
want to
want
say
to
that.
indicate it. Yeah, exactly. You never want to indicate it to an unauthorized. So it's always, hey, either one is incorrect. Okay, so then here's my next question for you guys. We know that they're required. What happens if this password is blank? And if you don't know, just give me a guess. What do you think is going to happen when I hit the send button?
Depends how the backend's
Oh,
set up.
how the backend set up? That's true. That is true. Let me ask, is George available?
Yeah.
All right, George, what's your guess? You saw what happened when the password's wrong. You can still
But
see the response, but what happens if the password is empty?
it's gonna ask you to fill in a password.
All right, so I'm going to hit send. There you go, my man. So exactly. So the backend is, this is called backend validation. Essentially, what we saw here is you can put in an incorrect password and it's going to say, bro, that's not right. But if you have no password, it's going to say that it's actually a required field. So then here's the next question. And this isn't my site, because this is a different backend though, just heads up. But here's a live front end. This is an Internet Archive, which is pretty cool. Everything on here is free. They have like old games and old movies. It's worth checking out if you're bored. But my question is here. Let me clear this out. Here, I'm going to put in a fake password. Also, this is a fake email here. I'm going to log in, and here I have a 400. You see how there's three? That's not right. I want to see if it's open source, and I'll help them with that. But here it's 400. And what does it say? It says email address or password incorrect. So similar to what you saw on the other backend, right? But then here's my next question. What happens if this is blank? And I hit login. Does anyone have, or actually, George, let me ask you again. So far, you're 1 for 1. Now that this is blank, what's going to happen when I hit login?
Wouldn't it be the same thing? It asks you that's required field to fill in a password?
So the answer is correct, but what's going to tell us that? Is it going to be the backend?
I don't know. It depends on Roger.
And if you don't know, it's okay to guess.
I guess if you had a properly set up front end, it should catch it right here.
Yeah, it should, because how is it gonna tell you that it should tell you, yeah,
Okay.
on the
So
front
I'm going to
end.
hit login here. And I want you to notice exactly. There was not another request, right? Not another network request, but instead the front end caught this. And here it says, please fill out the field. So exactly how Nix was set up, actually. And this is called front end validation. So even though the backend can handle this being empty just fine, the front end is also handling it. And one of the benefits is it's actually reducing unnecessary API calls. It's now, we're not even bothering the back. We're handling it at the lowest level, if you would. The reason why I showed you this, so I appreciate you guys, participating with this portion, is because slots, right? Slots are required parameters. It's essentially what I just showed you, like the same way the username and password are required parameters for that specific endpoint, the slots are required parameters. And now, in the same way that in the GUI that I showed you on the Internet Archive, it didn't bother the backend, right? Instead, it handled it on the front end and said, hey, dude, you need this. That's exactly what slot elicitation is. So from here, when you say, hey, move 200 to my savings account, it's not even going to send it to the backend. It's going to say something like, which account would you like me to transfer it from? Let me ask, did that example help anyone, or was that completely unnecessary?
That's a good example.
Okay, cool. I was just making sure. So here are some examples of slot types. Now remember the slot themselves, like the slots themselves can be anything that you want it to be, whatever, well, specifically what you need it to be. The types are literally just the types, the same way we type check everything else. So here, if you have just an example, Amazon.number, that would be that the input for it has to be a number. So like, for example, for the slot amount, we would make that Amazon.number. So then it could be 5, 27, 100. And it doesn't matter if it's a literal number or a string. Well, technically, we're only working with strings, so let me rephrase that. It doesn't matter if it's the number typed numerically or spelled through characters. It's going to convert it into the number that it needs to be. We can also utilize a date, a time. There's a bunch of types. I think there's like email, city. They're all like pre-made. And we can see that when we go to the console. So here it just says that this handles the parsing for you. So if a user says next Friday, and Lex returns an actual date, you know, instead of next Friday, it's going to return that, whatever that physical date is. So here, what else does this say here? So a real business needs custom slots too. Product names, department codes, priority levels, vocabulary that's specific to your domains, like just, you know, the jargon of your company. And you can create custom slots that match your business language, marketing, or making conversation feel natural and domain specific. And it says we'll build some of these in the lab. We're not building them today unless they're part of the challenge. I honestly don't remember, but if not, it won't be part today. So then there's something called fulfillment, right? Because right now you have the grasp of the user saying something, we're getting the intention, making sure we have the slots for it. Then we actually need to do something with it. We need to fulfill this request. So fulfillment's where the conversation meets action. When Lex has everything you need, it has all the required slots. Here it says intent identified, slots filled. It calls your fulfillment function to actually do the work. This is where your existing Lambda functions, those are serverless functions. I believe you guys already played around with those. That's where they become powerful. Instead of a user calling transcribe API directly, they're going to have this conversation. So here's another example. Can you analyze the sentiment of my presentation recording? Lex will say, sure, please upload your file. That's a slot elicitation. The user can upload the file at that point. And then Lex can call transcribe lambda, and then it will call comprehend lambda. So it's hitting those two APIs. This is part of fulfillment now. And then it's going to have its output. Your presentation has an overall positive sentiment of 92% confidence. So here, essentially what it's saying is that these were two Lambda calls, but it was actually from the conversation or from the user perspective, it's just one conversation. It's one seamless conversation. So the user doesn't know and the user doesn't care if you have multiple services or what's going on, and they shouldn't know. Here's a disclaimer. If you're building anything with Lex, use Lex v2. You're going to work with Lex v2 for the labs. It's the current standard. So v1's essentially outdated, and I think they're going to deprecate it anyway. But AWS recommends v2 for all new projects, and it's what you'll encounter in actual like business production. Some of the improvements of v2, if you're curious, bot locales. It supports multiple languages in one bot, and it's useful when your users aren't all English speakers. And that's obviously from our perspective. I'm sure if someone was in French, it would probably say it's useful when your users aren't all French speakers, you know. And then there's improved slot elicitation, which you know is important. That's so we can get the required parameters. So it has better control over how Lex asks for missing information. Then there's streaming conversations. It's real-time voice interactions. And it says you're going to learn more about that later in this week. So Terraform, you guys know this and love it by now. Or if not, you're in hell because you're going to keep using it. So Terraform has solid v2 support now. So we can provision everything as infrastructure as code. The AWS Lex v2 model, you'll see this later. This CLI command gives you full control over bot configuration, which becomes important when you're debugging or automating deployments. Here's just a quick little overview of the week ahead. Like I said, today's a quick class. Today, we're going to understand the fundamentals and work with Lex through the console and CLI. Today, we're actually mostly hitting up the console, but it's a good thing, and I'll touch on that later. By the end of the lab, you're going to have a working bot that you can talk to. Don't get your hopes up. but you are going to have one. It's just not going to, be all the grandeur you're expecting, but that's the process. Tomorrow, you're going to provision the same bot using Terraform. You're going to what does it say? Manual console work becomes reproducible infrastructure. So then you're going to convert what we do today into the CLI portions. Day 3, we're going to scale Lex resources using advanced Terraform patterns. You're going to use count for each and lifecycle management. On day 4, all day long, AM and PM, you're going to replace your React apps direct API calls with conversational flows. The users won't call 3 separate endpoints. Instead, they're going to have one conversation that's orchestrated by the AI. If you want to know the goal for the whole week, you're going to have a system where someone can ask a question in a natural language and get an intelligent response back by multiple AI services. I'm going to stop here for a moment. Does anyone have a question about anything that we talked about before we get into the importance of the CLI? Or was it pretty straightforward?
Jonathan, I had a question before you talked about Lex V2. That was that example of a user uploading a file, and we went from transcribe lambda to comprehend lambda, right? If we would have known that that was going to be a potential use case in order for that to happen, right?
You're
Like,
saying us, the devs?
yeah,
Oh yeah, no, everything is going to be like indicated if that's what you're asking.
yeah, like, okay. Yeah, because we probably would have built it if we actually let the users upload a file to begin with.
Wait, say that portion again?
So right there, that conversation uploads a file, right?
Hmm.
Um, that that assumes that we plan for that, right? So we allow them to upload a file, and then with that, transcribe and comprehend were potential options for us to use.
Oh, yeah, exactly.
Yeah,
Everything's going to be indicated.
yeah.
And
Okay.
that's what's going to happen this whole week. So today, literally, we're just handling the input, understanding intent, and slot elicitation. That'll be the extent of today. But you're correct. You as the engineer will know because you're setting everything up, and that's part of the architecture portion. So CLI, command line interface, why does this matter? This is usually opposed to using the console, the AWS console. You're going to spend real time with AWS Lex V2, CLI commands in the lab. And then here's why you don't skip this. The console is great. The AWS console is great for exploration, but it does hide details. When something breaks, you need to see the full configuration, and CLI will show you everything that you need. When you need to automate deployments, you need scriptable operations, and CLI provides them. And then tomorrow, when you're actually using Terraform, you're going to notice that the CLI commands map directly to the resources you're defining, which would be the same structure, the same patterns. So understanding the CLI will help you understand Terraform and vice versa. So most tutorials skip CLI work, like if you guys were doing a follow along on YouTube. And that's because it's less visually satisfying. And we're not skipping it because employers are going to expect you to actually know how to do it. Now, I just want to say this because I don't want anyone jumping on me later. Today, we're using the console for 80%. And it's not because, oh, we're disregarding this. It's because we're doing the initial setup. And I did look into the CLI, like, oh, like, is there a better way to do it through CLI? And this would be one of the instances where it's not better to do the setup with the CLI, just because it's kind of like, it would be like I don't know, a spider web of JSON. It's like, it's not practical. So even though we are stressing the importance of the CLI, what we're doing today would be one of the better alternatives or a better use case of when you're not utilizing the CLI. So we are going to use it, just not for the initial setup, and you'll see that in a moment. So today, by the end of today, you're going to have a working bot that understands natural language requests for the AI services. It's going to collect required information through conversation, through the slot elicitation, and it's going to return structured data that's ready for Lambda fulfillment. It's going to use the serverless functions to actually complete the task. Before we start this lab, anyone confused so far, completely lost? And it's okay if you don't get 100% because that's where the lab's going to close the gap. But is anyone super confused? All right. Cool beans. You guys are Outstanding. Let me see where I have this at here. Actually, cool. Let me see. Hold on, I'm just gonna move you guys out of the way real quick. And then I'm gonna put you guys back. All right. So for our lab today, it's just a fundamentals lab just to get us rocking. If you would like to follow along, you can. It's not so much work today, like where you can't just do it when I release you to do your challenge. So especially like if you have one screen, I know one of you has like one screen at least. You may want to just follow along and then, or I mean, just watch and then do it later. It's up to you though. But like I said, today will be pretty straightforward in terms of the console aspects. So think of the last time that you called customer service, right? You had to navigate through what's called like a phone tree, where it's like press 1 for billing, press 2 for this, press. Instead of that, imagine the same thing, but you just say, hey, I need help with my bill. And then the system actually understands what you want. They know your intent. That's what we're building today. By the end of the lab, you'll have a working bot that understands natural language, and collects the information it needs through conversation. This is a little misleading. It doesn't truly understand language. And I'll talk about that when I get to that portion. The objectives. 1, we're going to create a Lex v2 bot through the console. 2, we're going to configure intents and sample utterances. We're going to set up slots, those are the required parameters, to collect required information. And we're going to test conversation flows. And then, of course, we're going to use our CLI to actually inspect it. Here it says 60 to 90 minutes. I don't remember it taking that long, but we'll see what's up. So let's get cracking here. Actually, what would it be? So step 1 is to create the folder, which I've already created this directory. It's called, actually, here we don't need this anymore. And I'll delete this too. All right, so it's called Lex Fundamentals. And here I'm going to create this file first, the bot-config.json. We're currently not going to use it because there's nothing that we have to put in there yet. So that's essentially that. So now we're going to create the bot. What you want to do if you're not already in it, if you're in the AWS, you can just type in Lex, type in whatever service. Here it's Amazon Lex. We're going to go to it. And from here, you can see there's already some existing bots. For now, don't touch it. Because we don't know how other people are utilizing them. And right here, the big call to action, create a bot. Now, there is an option for generative AI. Here it says it describes the type of bot you want, and then they're going to do it through magic. So now it's like a bot building your bot, but we're not using that. So click on traditional, and we're going to create a blank bot. This is so you can actually understand what that generative AI would do for you. First thing we're going to do is name this. And what we're going to do, and going forward, I think if it's not explicitly stated, whenever you create anything, add your name on the end of it. And this is just because if you guys know about our whole EC2 instances right now where we don't know who has what, just make sure you're slapping your name on things until we get a more formal procedure for that. So here, anyway, this bot, I'm calling it AI Service Bot -Zion. That's my last name, if you don't know. This description is optional, so I'm going to leave it alone. And let's go down to, so actually all of this is optional as well. This IAM permission is optional. If you want to error log, it's optional. I mean, we can click enabled, but since we're using the CLI, I don't think it really matters for this. Children Online Privacy Act, doesn't matter for what we're doing, but I'm going to put no. And then from here, actually, I have to move you guys over because, there we go. Okay, so that's essentially it. Let me double check these. Yeah, we don't need any tags for what we're doing. So all we did so far is click traditional, blank slate, bot name. Everything else is optional, and we're clicking next. What happened here? Oh, this isn't. Okay, so I was wrong. It's not optional. For this, for the runtime role, just create a role with basic permissions. If you use an existing role, you have to know what they do or pre-create one. So in our case, just create a role with the permissions that it wants to do. Now we're going to click next. I wonder if my internet's slow, because this is a very slow load. There we go. For select language, we're going to pick English. The description is optional. With a real bot and real projects, because like I said, this is just like a sample, right? So we can test through it. The descriptions are helpful, especially if you're going to have multiple bots. You may forget why you created one or what one's being used for. So even though today we're skipping it, oh, actually, no, we're not skipping it today. Look, we have one pre-made. All right, so here it just says for our description, a bot for orchestrating AI services like sentiment analysis and translating runtime roles. And then what else are we doing here? The voice interaction. For now, actually, we're going to put none because today we're only working with text. We're not doing any sort of voice. And then speech model preference, none. And then I think that's it for this. Oh, the confidence score. Oh, this one's interesting. So if you remember that the bot is going to figure out the intent of the utterance, correct? It may seem like a good idea to say, oh, wait, let's put this at 100, like 1, which is essentially 100% confidence. But there is a disclaimer that the confidence score controls how certain Lex needs to be before matching it to an intent. So 0.40, that's a good starting point. It's high enough to avoid random matches, but it's also low enough to handle natural speech variation, right? If it's too high and someone doesn't say what it's trained on, it's never gonna really match. So yeah, it's kind of strange. If you remember, I think another class I had mentioned that a lot of AI is about like reducing errors. That's really what it is. And that's kind of right there. Not everything's 100% and it's not supposed to be. All right, so what else are we doing here? Okay, so we're already at this intent portion. Intent, new intent. So first thing we're going to do is name it. Actually, hold on. Oh, yeah, right here. I was just looking at instructions. I got lost in the sauce looking away from it. Is this the same page? Okay, yeah. I don't know why it looks different. I think because it's cramped on the smaller screen. All right, so we're going to create an intent. Remember, that's the whole purpose of this. It has to figure out what the user wants. For this one, analyze text. So what we're going to do, and we're not even doing it to the full extent, but what we're going to do eventually is if the user says like, hey, dude, I need to know the sentiment of this poem or whatever, that's analyzing text. So this is one of our intents that we're predefining here. What's important, so we can skip all this for now. Just know analyze text is the important thing. If we scroll down to sample utterance, and then we're going to skip this too because it wants to do everything itself now, but we don't want to do that. So let's put in an example. First one, we're going to say a user might say this, analyze this text for me. That sounds reasonable, right? So we're going to add the utterance. It's going to put it right here. All right, cool. It might also say, this one, what's the sentiment of this document? From a human perspective, would you agree that these are both the same thing? The two different users are trying to accomplish the same goal? Here's a shortcut. As you saw, we are using this input field to add it. If you click on plain text, it's right here. So now what I can do is, I just wanted to show you that it is already saving. There we go. So now we have more options. So someone could say, hey, can you check the sentiment of this message? I need text analysis. Check this text sentiment. It's just variations of the same thing. And then if we go to preview, here's each of our sentiment or utterances, sample utterances. And then here it just says, notice the variation, different verbs, different phrasings, different levels of formality. These the varieties can help Lex generalize. Adding an analyze text and analyze this text doesn't help much because that would be too similar, right? Analyze text, analyze this text. That's not the same as saying analyze this text for me. Can you check the sentiment of this message, right? Those are two, each one should be distinct enough that it's creating variation. And then once again, Lex will close the gap between all of these, or should, with at least a 40% confidence. Okay. So now that we have this portion, if you guys remember, we also need slots, parameters. So if we were creating this bot that semblances that this bot can analyze text, at least we know that's one of the intents, we're going to need to add a slot. So let's add a slot. For our example, we're going to call one slot text to analyze. The slot type is going to be alphanumeric, and then a prompt right here would be, what text would you like me to analyze? So just based off of today's class, what is this prompt? Do you guys remember what it's called, how it's being
Slot
used?
elicitation.
Correct, slot elicitation. So exactly, if the AI deems, if Lex deems that this slot, this parameter, this slot has not yet been provided, it's going to elicit, slot elicitation, it's going to provide this prompt. Say, what text would you like me to analyze? Now, here's where it's cool, because we already know, now we have one slot. Here we have our text, and we're going to go back here, and we're going to replace these. And we're going to actually come back here. I just want to demo something to you while we're here, because like I said, today's a short lab, so we have time to kind of like play around. All right, and it's not like we don't have to rush like last week. So here we updated this. If we go to preview, oh well, just real quick, here in the curly braces is the intent that we created, and you'll notice like in JavaScript, like whenever you use curly braces, it's more of a live variable, a defined variable, more so than just plain string. So even if we go to preview, here you notice all that beautiful blue. It's here it understands that this is the intent, that it is something we had defined right here in the slot, where we have the slot text to analyze, and then here we have we have the slot. And like I said, we'll get back to this in a moment. And then here it says we can add a closing response as well. That is right here. I don't remember doing this portion. Oh yeah, I do. I'm just trying to remember now. Right here. Oh, okay. So with this closing response, before it fulfills, remember it has fulfillment where it actually sends it off. This is essentially the companion statement, if you would, right? Once it has everything, in this case, it's just saying, hey, I'll analyze, text to analyze, and return the sentiment analysis results. And that's reassuring the user that, hey, this is now in progress. And then, yeah, from here, we could just tab off. So it doesn't have to save it in here. Now we're going to click Save Intent. Cool. What I'm going to do, and this is a little different from the steps if you're doing the follow along, because the steps are going to have us create another intent, which we are going to do. But for right now, what I want to do, since we saved it, is I want to show you that if we go back now up here, right to this tree, if we go to intents, analyze text. So we did create it. That intent is real. I want to show you this as well. Right here, we're going to go to build. This takes about 30 to 60 seconds. And when it builds, we're going to test this analyze text. And some of you may be disappointed with the full capabilities, and that's kind of that's going to be the point. I do have a question while this is loading. Does Lex understand English?
You talking about like a conceptual understanding of English? No, I would say no.
So we have one, I guess that's a guess, one guess for no. Does anyone agree or disagree?
I agree.
Does anyone disagree? Does anyone feel that Lex does understand English?
Lex does understand English.
Oh, my man. He said that as a great
I'm
actor,
proud.
I can tell. Great delivery. Okay, we'll get back to that in a moment now that the build is done. So what we can do here is test. And then let me scroll down. So we're on step 4. So remind me if you guys can remember, we're going to go back to step 4. But as of right now, this is what I'm going to do. If we jump to step 5, build and test, I'm going to go ahead and ask it a question, which says, analyze this customer review for sentiment. I'm going to hit enter. What just happened? If you can't see it, actually I should ask before, if you can't read this small chat, the response says intent fallback intent is fulfilled. What happened? Or what's happening?
It looked like it triggered that fallback intent, which is the default intent when no other intent matches.
Why?
Your analyzed text didn't have enough confidence. What was the term we used in the thing we set to 0.4? Intent classification confidence score. Maybe
Confidence
didn't meet that threshold.
Confidence score is a term
be
that
content,
is
though,
always
right?
appropriate within AI. I'm sorry, what'd you say?
It would have to be content because, as you mentioned before, it needs because the slots themselves act as functions, right? And you still need to fulfill all those requirements, right?
No, but that's a solid guess. If we didn't
Mm,
have the slot, it should give that message we prepared. That would say, "Oh, what's the slot? Or what's the uh,
right. You're
thing you
right.
want to?" Yeah, whatever it
Prompting
said.
for like you mentioned the prompt, yeah.
Correct. So here's why. Let me show you guys. If we go now back to this, which one does this closely match? So here we can see
First one.
the first one. So
Well, analyze, text to analyze. And then it also includes the word sentiment, which is included in the second and third ones.
So here's the thing. So based off of your human, you're correct. Which one does it most closely match? It is this. But if you want to say which one does it match to Lex, it's none of them. Does anyone know why?
Mm.
And I'll tell you that the answer is right here. You can see the answer.
Does the customer review
What about it?
that wording?
That's fair. But essentially what's happening here is in all of our utterances, 100% of this training data, we're saying that essentially, well, I guess we could say intent. This intent is explicitly provided. The parameters specifically provided. Everything's provided. Because remember, this is essentially, code. It's not really code, but it's code. It's referring to something specific that's already defined and has required parameters. And now it's saying, dude, nothing you said is matching this. So check this out. You guys remember those original ones we put? We still need them. That's going to handle both cases with and without. So now I'm going to save the intent. Did it save? Now I'm going to rebuild. And it says bot's not ready for testing. It takes about 30 to 60 seconds. And then I'm going to go back to my previous question. Well, we'll wait for this to build so you can see this result. While this is building, does anyone have a quick question for me? Or so far are we all just tracking with this lab?
Why did you need both? The curly brackets text to analyze and the ones without them.
So if I'm fully understanding it, I believe the reason is because it doesn't know English. So if this is all that it knows, every example is saying, hey, that this intent is provided. Not the intent itself to say, oh, like here's the answer, but the parameter of the intent, which is like the actual document, the actual text to be analyzed. So in this case, it's saying, dude, everything I know, you're supposed to not only say something similar, but you're also supposed to provide this thing, and you haven't. So it's just saying, here's the default, I don't know what to do. But here we're explicitly saying, hey, look, actually, humans are going to just ask you for stuff and not provide everything. So then at least in this context, what it's going to do or should do, we'll find out right now, is it's going to, I'm just looking for this string so we can put in the same sentence we put in before. Here we go. Actually, this wasn't the same string. This is it. So what it's going to do now is it's going to understand that sometimes the parameters are provided, sometimes it's not. So here's the same prompt from before. Analyze the customer review for sentiment. Now what does it say?
Yeah. What text would you like me to analyze? Yeah.
Yep.
Just asking you to provide it. Yeah.
And that's because now it's been trained on I mean, if you kind of want to say two different, what do you call them, like routes, if you would. The happy route where everything's provided, and the not happy route, which is mimicking the human experience. So for a moment, let's go back to that question I asked. I said, does Lex understand English? And only Nick was foolish enough. I'm just kidding. Obviously, you're playing along. I appreciate you. To say it does. It doesn't. It doesn't know what the hell we're talking about. What does it do then? It knows patterns. That's why this training data, you just saw it. You saw it. If we didn't have this pattern from 1 to 5 fulfilled, it didn't know what we were talking about. And if we inverted it, I believe it would have the same issue. So here was a hypothetical I had. I didn't get to play with it. I didn't have time today. I really wanted to. So I'm going to try it later this week. But I did talk to Gemini, powwowed with it. Here's my idea. If it doesn't understand English, does that mean here I can make up my own code? Now, when I say code, I don't mean JavaScript, Python. I mean like coded language. Can I put in my own patterned nonsense, whether it's like numerical, alphanumerical? Can I write like, for example, let's say I had a membership portal, and to go into a certain room, you need a certain types of keywords, let's pretend. And let's say all of the examples I gave it were a color and a mammal. Oh, the blue fox jumps, and let's say the green dog barks, and we'll say an action verb at the end. If I give it those patterns and then I create an intent, which we know is a function triggering an API that now says like open the door, it allows them to go to a different thing. Would that work?
But wouldn't that run off tokenization where it's predicting like what would be the most likely probability of the next thing? And if you're going too far off, it's too much variety?
Solid question. It may. And if you're talking about now optimization and financials, like efficiency, it sounds like that was very solid assumption. Yeah, could be. In my use case, though, it wasn't necessarily about a functional business need. It's kind of to show you here that this doesn't understand English. And that literally, if you create your own patterns and then you assign it your own intent, it will have those patterns fulfill the intention, period. But here, when you create it in real life for your real use cases, you're going to use English, our understanding of commands of conversation, and then it's going to take those patterns and then go ahead and function. So this is what we're doing here is taking away the veil. AI is not what they're selling it to us, and not us as engineers, but us as like consumers. It's literally API calls. All this really is a different interface. Instead of a graphic interface, it's a voice interface. But anyway, that was just like, that's not in the lab, but that was where my brain went. And I kind of wanted to just share that, comparison with you guys. So what we're going to do now that we did this, we're going to go back to intents. Let's move this out the way. We're going to add an intent. So we're going to do the same thing we just did. Which step was that? Do you guys remember? Did I say it was step 4? It was. You guys broke my heart.
Yes, step 4.
Okay, cool. So this other intent is transcribe audio. So we're going to go ahead and add this. Same thing we just did before. For transcribe audio, for this one, we don't have any of this stuff filled out for this example, so we're going to skip them. We are going to go to the sample utterance. This time we're just going to go straight to plain text. And I'm going to just copy all of this stuff in here. There we go. So far we have some sample utterances for our audio, transcribe audio. So what do we need now? Oh, I'm sorry. I was calling them intents before. I meant to call them slots. Right now when we were talking about the previous, why the previous thing wasn't working. All right, so we need a slot. That's the parameter. So for this slot, it's going to be very similar because one was for text, this one's for audio. So we're going to call this slot an audio file. It needs to have that. This file is still going to be alphanumeric because it's about like what it's perceiving, not about what it actually is. And then the elicitation here, it just says prompt, but the elicitation, if it's not provided here, it's going to say, please provide the audio file location or name. That would be for the use case that we're not even setting up today. But we'll go ahead and add that. And then now that we have this actually created, right, we have the slot type of audio file. We're going to go back to our sample utterances here. And we're going to do that same thing. We're just adding more sample utterances. And here you can see this. The one thing I was going to show you guys too is it doesn't matter which one you do first. So what I'm saying is if you set up these sample utterances that reference these specific slots, but the slot's not created, that's completely fine. As long as you create the slot. You know what I mean? Doesn't matter which one you do first. Then now we need to do the fulfillment response. Do you guys remember what fulfillment response is?
Once intent has been identified and slots are filled, it can actually execute some action.
Correct. This is essentially the happy path saying, perfect, we're going to go ahead and do what you want. In this case, it's saying I'll transcribe the audio file, which is this the slot name, and provide the text output. And now we're going to save this intent. And then once again, if you guys just want eyes on it, you can go here. If you do want to test it, you are going to rebuild it. Whenever you make changes, you have to save and rebuild it. What's up? I thought I heard a breath.
That makes sense. That's really cool.
Okay, cool. Does before we get into the VS Code, because now we're done with the console, does anyone have any questions about what we just did? About setting up the bot, setting up intents, adding the utterances, sample utterances, the slots, and the fulfillment. Does that make sense to everybody? Okay, cool. So it's really cool because, like, I mean, in reality, now that we did this, it's like super simple. But of course, it's just like the first step. But it's still pretty amazing, like how streamlined I think it is through AWS. So now we're going to go back to our here. Now we're in our VS Code. I'm going to move you guys over back down here. Cool. If you guys remember, we did create a folder. It's called Lex Fundamentals. It does have one file, which is bot-config.json. We're not going to use this at the moment, but we are going to autofill it. It'll be pretty cool. So first thing we need to do is we need to know our bot ID. So here in the CLI, it's AWS Lex v2. That's very important. Dash models list bots. This is going to just literally provide the list of bots that we have. The same ones we saw in the console. So here we have AI services bots. Let's find the one that we're looking for. So if you guys remember, I had named it with my last name. So this is which means this is my bot ID that I need. For right now, I'm just going to take it. I'm just going to put it here for now. Obviously, it errors out. This isn't JSON, but I'm just putting it here for at the moment. So now that I have that, I'm going to hit Q to leave this. And what you want to do is, now we want to export those bot configurations. Wait, is that correct? Yeah. Okay, so I'm going to replace this standing string with our actual bot ID. And we're going to put this into the CLI. Cool. So here's all the config that we need to know about our specific bot that we've just made. But now it's stored in this bot-config.json. So it's all right here, essentially, like this whole portion. This is the ID of the bot we're referencing. You saw that. This is the command line to actually get the information. And then right here, this is where we're sending it to, which is my bad, right here, the file. And then if we take a look at this file, it has essentially the same information. So it has the bot ID, the name of the bot, the role ARN, which I think for our purposes, it doesn't matter today. And then data privacy, child-directed, false. That's the one that I had specifically clicked on. The idle session, I'm trying to think if there's anything else we need today. Well, we need to know it's available. That's always good. The creation date, last updated, which should be soon after there. Type, it's a bot, ever loading, enabled, true, ever log, excuse me, true. And this one we had manually set as well, if you remember. So now that we did that, we can look at the structure. So this is actually, I don't know why this is set up as a separate step. I should have fixed that. This is essentially just the same thing that we did, but now it's in your terminal. So it's like, for our use case, we don't need this because we're actually just storing it here. But this is just, just if you want to see it, I guess, or if you want to reference it or whatever it may be. And then here's some other things we can do through our console. Oh, because I can't see the bottom of the screen. Give me 1 second. I'm going to move you guys over again. Okay. Oh, so I'm already in here. I thought we were in a Vim. Okay. So here's a similar deal. Model list intents. And then here we have the bot ID, which now it can actually just pull in. We don't have to keep doing stuff. You know what I mean? We don't have to keep typing everything out explicitly. Here I'm going to hit enter, and we're going to see the intents. So if you guys remember the intents that we created transcribe audio, analyze text, and then this one was built in as a default, right? The fallback intent. So we know that's working. We're going to quit here. Now we want to get details of a specific intent. Oh, actually, no, sorry. I forgot that we need this. For analyze text, I'm going to take this. And once again, I'm just storing it here for a moment. It's going to break everything, and that's okay. And then I'm going to put this command in here. Okay. So now what we're doing is we're checking out the details of a specific intent that we just saw in our list of intents. We know it exists. So here for this specific intent, if you remember, we created a bunch of the utterances, right? These are sample utterances, as you already know. And this is what they look like. These are all the ones that we just specified. And then this is good too, because remember, if you're working on a project, you may not have personally created all this. And now you can reference, see which intents exist, get the ID, and then actually see what it's trained on. You can also see the slot priority, which is something that we haven't done yet because we only have one slot in each. You're going to do that later this week. The closing settings, you should know that right here. This was the fulfillment statement, if you would, which I guess more of a pre-fulfillment statement because it's not really based on the response. It's just saying we have what we need to contact fulfillment, if you would. From here, I'm trying to see if there's anything else of super importance for what we're doing today, at least. No, I mean, essentially that. And then aside from that, so we pulled the bare intents, looked at a specific intent. That's step 6. For step 7, now you can test via runtime API. So what we can do here is send the message. So I'm going to delete this. I'm going to post it here. I think it's a little easier to read. But essentially, here we have the same starting point that we have. Recognize text. And it's going to pull in our bot ID again, whatever, same session. What's important is this right here. So this flag with text, it's I want sentiment analysis. This is now the same thing that we did in that test box in the console, but now you can do it right here in your CLI. So I'm going to cut this, paste it in here. And now what you'll see is, here's a response. This is what you would display to your user. Or, well, that's if it's just strictly text. If not, you would have it convert. But this is the output. What text would you like me to analyze? Does anyone know if that's correct or not?
That sounds right to me.
That's because it is right. Essentially, what happened is we didn't provide a slot. So it doesn't have the parameter it needs, so it's eliciting for that. So that's working fine right there. And then... oh, here, let me send that again, because here it does explain some of these fields, so I guess we can talk about some of these. I mean, to me, this is obviously the most important one. It shows that it's working. So here, if we go to session state, and then we look for intent name, we know that it's it did figure out the intent. So that's good. It just, of course it did. If not, it couldn't elicit for the slot. And then if we go to intent states here, it's in progress, which makes sense because it's obviously not fulfilled. And then intent slots, let's see if we can find that right here. Text to analyze, that's the one that we created. And then interpretations, let's find this right here. If you guys remember the confidence score, we need at least a 40. Here, it's 86. So that's something you can play with as well. Is just send it stuff and see where the confidence is. And if it's like super low, then you can know to provide different sample utterances for it. Because a lot of anything that you're doing with AI, especially with the response, a lot of it is trial and error. Like anything that deals with confidence rating is a lot of trial and error. So just know that. That's the extent of this. What I do want to show you as well is here in the console, which you shouldn't need now that you can do it through the CLI. But if you click on this inspect, it should show you. Oh, I thought it. Okay, I thought it actually showed you the confidence here. Yeah, no, this is whack. So there you go. Another good reason to use the CLI. You got everything you need right here. In the lab, we do have the steps to clean up. So for me personally, I'm gonna just go ahead and do that because I'm not doing the assignment. So I'm gonna do this. I'm running this delete bot, and here it says deleting, which as far as I'm concerned is deleted. And then here, if I go to bots, we should not see mine anymore, and we don't. For you guys, hopefully if you're following along, you did not just do that, because then you got to redo it. Wait until like the end of the week, because you are going to keep, well, I mean, here it says that you can remake it tomorrow. So I don't know, just go with your best judgment. Just make sure you delete it by the end of the week when we're done with all the labs. And then, so what did we build today, right? Some of you may be like, wait, is that the whole lab? Well, it is. This is the first, like the most important foundation for the rest of what you're doing. But today, what did we do? We recognized natural language. With recognize, not understand, but it recognizes natural language requests for 2 AI services. It collects required information through conversation. And it exposes runtime API for application integration. And it has configuration that you can inspect, and export via CLI. So I'm going to go ahead and stop the recording. Give me one moment.